benefits of doubt. Understood? So let's begin right away. This is actually part 2 of a video I started yesterday on boiling. I don't have to ask you. Someone said to me, it wasn't this class, they said, we can't do outlines, but how are we supposed to learn so quickly? You want to move in, you want to do this in 2 weeks, you just want to do a whole week of lessons and do labs? How can we do that? How can we learn the chemistry that quickly? Well, the reason is this, because we've hit a very conceptual area. Before you came in here, most of you had no real understanding of first ionization energy levels. How many people knew about first ionization energy levels? Raise your hand. Nobody's raising their hand. Maybe T, maybe you heard of it, T? Yeah. Okay, but you had chemistry before you came in here because this is the middle of the year. But before this year, T, did you know that as you move from left to right across a period on the periodic table, the ionic radius decreases dramatically and then increases dramatically and then decreases dramatically? Did you know that?
No, I learned that.
No, you only learned it this year, but you didn't know it before this year, did you? No. But we've reached a very conceptual period of our study of chemistry. You could almost say that we've started chemistry. Even though we're looking at the physics of chemistry, we've actually started more of a study of chemistry. And how do you know that? I'm going to ask you a quick question. And the answer to this question, if it's affirmative, that means that we're studying chemistry. If it's not affirmative, then we're not studying chemistry and you're from another planet where physical laws are different. Okay? How many people in here have ever boiled water? Raise your hand. Everybody in the class is raising their hand. Maybe a Korean back here. Have you? Oh, you are raising your hand. Are you? Okay, excellent. So, you're from Spain. So the Spanish contingent has boiled water. Okay, what about Angola? Have we boiled water in Angola? Excellent. All right, Atlanta, Georgia, weird place, but have you boiled water? So we boiled water in Atlanta. The UAE, have we ever boiled water? Maybe your cook has boiled water. I mean, that's an interesting question, Z-Man. Have you, now be honest with me. Be honest with me. I'm not going to make fun of you. Have you ever boiled water?
Yeah.
You have?
I made noodles.
You made, he made noodles. How many times? Once?
No, I don't.
You made it a lot, excellent. Have you ever made tea for yourself?
Yeah.
He has. He had to think about that though, excellent. Where else? Belgium? Have we boiled water in Belgium? We've done it in Korea. We have quite a few Korean. Filipino? Where? Philippines. Have we boiled water in the Philippines? We have, excellent. Excellent, nice to know. How about Brazil? South of the equator, I want to know. Have you boiled water? Excellent. So we've boiled water in Korea, we've boiled it in Angola, we boiled it in Atlanta, and we've actually have a prince of the desert has boiled water in the UAE. I like that, excellent. We call him Z-Man. Okay. So, you know what boiling is, correct? All right. But can you define boiling for me? What is boiling? What is it? What has to happen when you boil water? Eamon. Bubbles. I like that. All right. I like that. He's smiling too. He likes that. He likes the bubbles. Okay? Eamon is very easily entertained. Give him bubbles and he can rule the world. Okay? Maybe we'll call you Bubbles. Would that be offensive? I like that. I like that. No, we won't call you Bubbles. We'll call you Eamon, but we'll think of you as Bubbles. Yes. T. When liquid goes from a gaseous state to a liquid state, or a liquid state to a gaseous state. What did you say?
I said liquid.
You said liquid to gaseous. Excellent. I heard, it's a form of dyslexia. I heard the opposite. A little weird. Okay. So it bubbles, right? Okay. It goes from gas to liquid. Can somebody it goes from liquid to gas. Excellent. I like that. Can someone, I said it on purpose. Angola caught me. I like that. We have a guy from Angola sitting right up front. It's wonderful. Now, can someone tell me what evaporation is? What is it? Basil's like, wait a second, that's too easy. I mean, you know what evaporation is, Darcy. I mean, come on, right? Basil, put it in one sentence or less. What's evaporation?
Evaporation is the precipitate that goes out of anything boiling. So actually water.
You're being really extremely way too thinking. Keep it simple, man. Keep it simple. Is that what? Explain it to your mother. Okay? Explain it to your mother. Okay? Just be simple. I'm not saying that your mother's simple, but just like, every day, tell your mom what it is. It's simple. Be simple. Tell her what it is. What is it?
That goes out.
I'm your mother. I'm your mother. I know I don't look like your mother, thank God, right? But tell me what it is. Tell me. Son, tell your mother what is evaporation. Go on.
Steam going out of.
Steam going out of water. All right. I still don't really quite understand it, but anybody want to tell me? Yes.
A liquid turns to gas without boiling.
A liquid turns to gas without boiling. I like that. I like that a lot. I like yours too. Steam, water, liquid turning to gas without boiling. Now, remember what I said. It's awfully burdenous if I ask you a question, you feel compelled to get the whole answer. It's intimidating, right? It's weird how you know that now, but still, you don't want to participate because you feel compelled to give the whole answer. But look what he did. He gave part of the answer. That's actually quite true. Is it the complete answer? No. But that doesn't mean it's a bad answer. It's a great answer. It's part of it. What else? Evaporation. Where does it take place? Is there a place where evaporation takes place by definition? Where? Atmosphere. Where? What? Too general. I want a specific place. Yes? On the surface. Excellent. Right here. Where I have evaporation on the surface. Vaporization is simply the process of liquid to gas. Vaporization is a what? Is a change of state, correct? That's what vaporization is. Evaporation is that change of state, same change of state, but at the surface. Now, we know when molecules hit each other, you get pressure, correct? So we know that evaporation is taking place here, and we know that those molecules are causing pressure. They are. They're causing pressure. They're bouncing off other molecules. We know we have an atmospheric pressure. We did a film on atmospheric pressure, so we know that exists. Correct? The atmosphere is a liquid. Where's the liquid thickest? It's not a liquid, it's a fluid. The atmosphere is a fluid. Where is that fluid thickest? Down near the Earth because of gravity, or up in the mountains? Just an FYI for your information. It's down along, it's down on the sea, right? Down on sea level, right?
Yeah.
That's where it's thickest?
Yeah.
So the pressure would be greatest at sea level, correct? Yes or no? Okay, good. Just a FYI. Excellent. So, we're going to do this at sea level. Is that okay? So we know we have an atmospheric pressure. We know we have a vapor pressure. You don't think of a vapor pressure, do you, when you boil water, do you? You don't really think of that, do you? You don't really think of atmospheric pressure. You may think of atmospheric pressure a little bit more now, but you didn't really think of it much before, did you? Okay. Evaporation is occurring, right? That's a bubble. That bubble has pressure. We're going to call that pressure vapor pressure, correct? What's preventing that bubble from forming? What's preventing that bubble from forming? The what? Go ahead, say it, Alex. You can say it. Starts with an A.
Air resistance.
Aiden, you were about to say it.
No, I think I was wrong.
What were we going to say?
I was going to say atmospheric.
That's right. You were not wrong. You were correct. the atmospheric pressure is preventing that bubble from forming. It's preventing it from forming. Right? It's preventing it. Right? What happens though when your vapor pressure and your atmospheric pressure are now equal? There's no, one's not greater than the other. What can happen now? What can happen now? Yeah, exactly. Yes, go ahead. Yeah, you can form bubbles. You can form bubbles, and they pop up. Yeah. When the atmospheric pressure equals the vapor pressure. When they're equal, you form bubbles. And that's what boiling is. At sea level. At sea level. What's the temperature of boiling water at sea level? Where the atmosphere is thickest. 100 degrees Celsius. That's boiling. It's right in the book, right in those first few pages. What is the pressure on top of Mount Everest? I think it's in one of those first few pages. Yes, Aiden, what is it?
34.
What is it?
34.
So Everest now, sea level, what's the pressure at sea level? What is it? Well, we say 100 kPa. Yeah, 101, whatever. Well, 100 kPa, correct? And at Mount Everest, it's what? It's significantly less, right? When I first read that, and I've been doing this, do you realize that I've been doing this my entire adult life? And every time I see that number, you know what I say? My entire adult life I've been doing this. To the point of sheer boredom. I mean, how many times am I going to teach the same thing year after year for 35, 36, 37, 40 years? 41 years I've been studying this stuff, 42 years. But you know what I say still? Wow. Wow. What's the boiling point of water on top of Mount Everest?
70.
What is it?
70 degrees.
70? Is that what you said, 70?
Yes.
Yeah. 70. Isn't that amazing? Isn't that amazing? So, the higher, think about, why do you think I went over my first lesson was atmospheric pressure, right? The farther you go up in the atmosphere, because it's a fluid. A fluid is anything that, Alex, who defined this? Somebody defined it in here. What's the definition of a fluid? Anything that flows, right? So you have this liquid, this fluid called what? Called what? Air, and it flows, right? It flows. Yes? It flows. And that flow will be greatest because of gravity near the Earth, correct? And it will be less thick as you go vertically up, correct? Yes? And you can see that you go, what's Mount Everest? 29,000 feet? What's it in meters? What is it? Does it say? What, say it again?
9,000 meters.
It's 9,000 meters. So you go up 9,000 meters, here's the pressure at sea level, here's the pressure at 9,000 meters. So we know that in the mountains, water will boil at a lower temperature. Correct? Are you okay with that? Okay. I'm going to come back in a minute. I'm going to stop this. And I want to talk about other chemicals. I want to talk about other chemicals, not just water. I've got to talk about other things besides water. Water is a good starting point. Why do we start with water? Why do we start with water? Because water is very common. Everybody's boiled water. Have you boiled acetone? No. Have you boiled alcohol? I hope not. You know, your parents may, your mother may have boiled. My mother used to boil acetic acid. What is he talking about? Yeah. Why would my mother boil acetic acid? And I'm going to answer that question on the next film. Okay? Clear? Be right back.